We're looking at another example of the midpoint formula. The problem says the midpoint of the line segment from point 1 to point 2 is negative 1, 4. We're given point 1 is negative 3, 6 and asked to find what the second endpoint is. So in order to kind of process this information, let's graph it and then look at it again. So the point negative 1, 4 is located right here, and we're told that this actually is the midpoint of the line segment. We have the first endpoint, which is at negative 3, 6, so this is point 1, and we're asked to figure out what is the second ordered pair somewhere down here such that the negative 1, 4 point is the midpoint of that line segment. There's a couple ways that we could go about doing this. Number one is to think about it graphically. Since we have integer values at which our points fall, we could just count to say that to go from point 1 to the midpoint, we went down 2 units and then right 2 units to get from point 1 to the midpoint. So we could just go down 2 and right 2 more to get over to the second ordered pair, which we will algebraically find as 1, 2 in just a moment. Sometimes our ordered pairs don't fall on nice, neat little integers, so we really need a way to do this algebraically for those cases. So if counting wasn't an option, what we would need to do is say, well, point 2, this second ordered pair, is our unknown quantity. And let's identify unknowns or label unknowns with variables. So we don't know what point 2 is. Let's hold that place with x2, y2. But we do know what the midpoint is, and the midpoint is negative 1, 4. We also know that in order to find the midpoint, we would need to be averaging the x values of the two endpoints. So we would know that the average of these two x values is going to be equal to negative 1. Let's say that the x value, and bar over the top of an x means average, so x average is equaling to negative 3 plus this unknown x, and divide that by 2, that's going to give me the x coordinate of the midpoint. So my average x value is negative 1. We can then just use this as an equation and solve for x2. Let's say that we want to get rid of these fractions first by multiplying both sides by 2. Then we'll end up with negative 3 plus x2 is equal to negative 2 after I distribute this 2 into both sides of the equation. And then we can just solve for x2 here by adding 3 to both sides, and we can see that the x value of our second point, or the other endpoint, is positive 1, or has to be positive 1 in order to satisfy that equation. Now, in order to get the y value, we know that the average y value is going to be the average of 6 plus y2, and that's going to be equal to the y value of the midpoint. So we would say the endpoint y value 6 plus the endpoint y value that we don't know, that average has got to be equal to 4. So we can use this then as an equation and solve for y2. Again, we're going to want to multiply both sides of this equation by 2 in order to clear the fraction. So we'll say 2 on the left is going to yield 6 plus y2, the 2's cancel. 2 multiplied here on the right is going to be equal to 8, and then all I have to do is subtract 6 from both sides to get that y2 is equal to 2. So the x coordinate of the other endpoint is 1, and the y coordinate of the other endpoint is 2, which is what we came up with a moment ago when we were determining this point by graphing or counting.